Okay, so I think in the last class we have seen Stokes theorem. So before going to start the next Gauss divergence theorem, now again I will revise the Stokes theorem. So Stokes theorem is the single integral to the double integral. That means the line integral of f dot dr is equal to surface integral of curl dot n ds, or you can take the dA. So the first one is the evaluate the single integral. The curve is here the a square region. This problem we can do by using the line integral as well as by using the Green's theorem as well as by using the Stokes theorem. Suppose if it is a line integral, so this is the square. So square means this curve, that means this path we can divide into 4 different paths, C1, C2, C3. So C1 just we have to take the AB curve, and C2 is the BC curve, and C3 is the CD curve, and C4 is the DA curve. So just solve separately C1 curve, along the C1 curve, along the C2, C3, C4. Now here we will get definitely the values are along the C1 curve 2 by 3, along the C2 curve we will get the 0, along the C3 curve 2 by 3, along the C4 curve 0. So we will get the 4 by 3, and we have this is the about the along the C1 curve. In the C1 curve just x is equal to 1 line and y values are running from -1 to +1. Just substitute, we will get the 2 by 3. Next one in the C2 curve, along the C2 curve, that means in the C2 along the C2 curve y is equal to 1, but x is running from 1 to -1, not -1 to +1. So 1 to -1, and dy is 0. Just total convert into in terms of x, we will get the result 0. And next one along the CD curve, that means along the C3 curve. So along the C3 curve it is x is equal to -1 and y is running from 1 to -1, not -1 to +1, and dx 0. After substituting, after simplification, we will get the 2 by 3 along the C3 curve. And along the C4 curve, along the C4 curve means we will take here y is equal to -1 and x is running from -1 to +1. So y is equal to -1 means dy must be 0. After substituting, so here we will get the 0 value. Now C1, C2, C3, C4, just substitute in the first one, we will get the result is 4 by 3. So this is the about the line. So derivation of this one in the regular approach, but same problem we will solve by using the Green's theorem. So Green's theorem, the statement of the Green's theorem is integral p dx plus q dy is equal to double integral of dou q by dou x minus dou p by dou y is equal to dx dy. Just the given problem, compare with this one. After compare, we will get the p is equal to xy and q is equal to xy square, and this is the single integral of p dx plus q dy. So that is the double integral of dou q by dou x minus dou p by dou y dx dy. After substituting, so dou q by dou x is the y square and dou p by dou y is x. Substitute. After substituting, we will get the, it is the double integral, and the x values are running from -1 to +1, and x values -1 to +1, and y values also -1 to +1 because it is the square region. And just do the normal double integral. You can evaluate first x then y, or you can evaluate first y then the x, that is your choice. After simplification, we will get the this double integral gives 4 by 3. So this is the about the Green's theorem approach. Next one, Stokes theorem approach. In the Stokes theorem approach, what is the Stokes theorem? So line integral of f dot dr is equal to surface integral of curl del cross f dot n ds. Now after first of all we have to identify the vector point function. In this vector point function, although it is clearly given here, single integral of xy dx plus xy square dy. So here this is the f1, it is the f2. Now our f is equal, vector point function is xyi plus xy square j plus 0 into k, and just to calculate the curl x. That means del cross f is equal to mod of ijk dou by dou x dou by dou y dou by dou z xy square 0. After simplification we will get the k into x square minus y, y square minus x, and here in this problem it has given in the xy plane. So in the xy plane means, so here the unit normal vector is the k, and just substitute all the results in the formula. So the formula is the surface integral del cross f dot n ds. So surface del cross f is already we have the result k of y square minus x, and here the n is k and dx dy. After doing so, here we will get the double integral y is equal minus 1 to plus 1, x is equal minus 1 to plus 1, y square minus x dx dy. Already we know that this integration result in the previous in the Green's theorem also we have the same results. So this, after doing the double integral, we will get the 4 by 3 is the result. Okay, so 4 by 3 is the result. So this is the calculation, but I am not going to discuss. Next one, the second problem is the, so here f is minus y and minus yz square j minus y square zk. So over the upper of surface x square plus y square plus z square is equal to 1, that is the, it is the sphere, center 0 0 and radius is 1, and bounded by in the projection with the xy plane. So projection with the xy plane means what about that? So projection with the xy plane means we have to take the z0, that means it is the upper view. Upper view, the projection must become, it is a circle. So circle, and the equation of that circle is x square plus y square is equal to 1 only. Projection on the xy plane. So here there are 3 questions. Now single integral f dot dr and verify the Green's theorem and verify the Stoke's theorem. Now first of all we will do the by using the line integral. So line integral, and it is clearly given projection on the, so projection the xy plane, so z is equal 0, dz is equal 0, and after taking the line integral f dot dr, so line integral 2x minus yi and minus y z square j minus y square zk dot dxi plus dyj plus dzk. After doing the vector dot product of these two vectors, we will get the integral 2x minus y dx minus yz square dy minus y square z dz. And already we know that here the dz is equal to 0 and dz is equal to 0 means we will get only this single integral 2x minus y dx. And this problem we can solve in the 2 ways, by using the Cartesian form or by converting the polar form also. But anyway here I am converting the polar form. In the polar form I am taking the x is equal to cos theta and y is equal to sin theta, because here the radius is 1, and dx is dx, it is the dx not dr. So dx is equal to minus sin x d theta, and the theta value is running from 0 to 2 pi. Just substitute. After substituting, here we will get the answer pi. So this is the line integral results. Next one, same. So same problem we will solve by using the Green's theorem. In the Green's theorem, first of all you have to identify the p and q, and here the p is the 2x minus y and q is the 0, and dou p by dou y is equal to minus 1, dou q by dou x 0. After applying the Green's theorem, here we will get the double integral of 0 minus of minus 1 dx dy. So double integral of 1 dx dy means it is the area of the region. So area of the region means, so it is the circle x square plus y square is equal to 1. Now area of this region is, area is 2 pi 1 only. Sorry, that is the perimeter. So here the area is the pi 1 square, pi 1 square. So pi is the result. Okay, or you can do the normal integration. In the normal integration, you have the 2 options. You can solve directly by using the Cartesian form, or you can use the polar form also. Anyway, here we will get the result by the result. I think this next one is the, so evaluate this line integral by using the Stoke's theorem. So the given vector is the F. First of all, you have to find the curl F, that means del cross F. After doing the curl F, you will get the K only. So in the xy plane, our unit normal vector is the K. And xy plane means x square plus y square z square is equal to 1 means in the xy plane we will get the x square plus y square is equal to 1 only. We'll get this result. And after applying the Stokes theorem, line integral is equal to surface integral, and del cross F is we have the K, and unit normal vector K, and here the xy plane means dx dy, and here we'll get the surface integral, that means the double integral 1 dx dy on the x square plus y square is equal to 1. So here we'll get the area of the region. What is the area of the region? We'll get the only pi only. And we can do this problem in the two more ways, by using the normal Cartesian form or by using the polar form also. Okay, so this is the results of the evaluation of the line integral, and by using the Green's theorem and Stokes theorem from 1 and 2. So Green's theorem is verified. From 1 and 3, Stokes theorem is verified. I think I have given homework problems, 3 problems I think. So I expected. So I think all of you done. Okay. So any doubts ఉన్నాయండి ఇందులో? I think doubts ఏమి ఉండకపోవచ్చు.